And really what we're going to do is look at 5 areas to focus on when designing workloads for Azure, along with some, good practices for each of them. So the first area we're going to look at is governance. So, understanding what you need to do from a regulatory, requirement point of view. If you've got certain standards you need to meet, you check out the Microsoft Trust Center. It has all the latest information, news and best practices around security, privacy and compliance. We spoke about landing zones earlier. If you're moving or designing a workload to run, is it going to sit within a landing zone? Consider the security controls that are already in place, things that you might inherit within that subscription. And have an understanding of how that impacts how you design and how you deploy that particular application. What security controls have you put in place for access to Azure, the Azure infrastructure itself? So, there's guidance there on reducing risk exposure in the scope, i.e., permissions for that account, and time when configuring critical impact accounts, like the administrator accounts, leveraging tools like just in time. In terms of identity and access management, again, following on from that kind of just in time, we're looking at restricting access as well, based on the need to know and least privilege security principles, those zero trust principles about least privilege access. And make sure you're assigning permissions to users, groups and applications at a certain scope using Azure role-based access control. There's loads of built-in roles. Try and use the built-in roles where possible. In terms of accessing resources within Azure, certainly from within an application, look at using things like managed identities. So you're not, having to put in any sort of username or passwords or any information like that, secrets into the code or for the application itself. Where possible, look at using passwordless methods. Things like Hello for Business, MFA, Authenticator app, or FIDO2 keys. And as much as Microsoft won't run older versions of operating systems, there are customers that are running IaaS legacy applications, and there are potentially legacy protocols and authentication methods that are available on the platform that you may potentially want to switch off when looking to design something new. So from a networking point of view, segmentation, look at segmenting your network footprint and then create secure communication paths between segments. This aligns with the zero trust principle of assume breach. So if someone manages to breach your one area of your application, so maybe like your web your web front end, they're not able to get to middleware or a database with key information in it. Design security controls that identify and either allow or deny traffic access requests between those segments, so you've got visibility of what's going on and what's being blocked and what's being allowed to pass through. If you do have public endpoints, looking at things like Azure Front Door, with its WAF capabilities, application gateway the same, or an Azure firewall, or indeed Azure DDoS protection. If you've got web public endpoints for if your application is a web-based application and you kind of live and die on the internet, so you can mitigate those DDoS attacks by upgrading to DDoS standard protection for those critical workloads. Gives you much more visibility of what's happening during a denial of service attack. So yeah, just to be clear, all services on Azure that are public endpoints get that DDoS protection included. However, the DDoS standard is a paid for service. It gives you much more information when attacks happen. Also gives you some SLAs of credits and stuff like that for should you get an outage. If you're running virtual machines, make sure you keep them private and secure when connecting to the internet. So going through virtual network NAT gateway. Don't just kind of control traffic traditionally, just in and out of kind of the perimeter, but look at traffic between subnets, controlling that east to west, and through your kind of application tiers. So from both front end back all the way through to a database backend, kind of referred to as north to south. And essentially for networking, it's all about building defense in depth with controls at each network layer, and that will help protect you from things like data exfiltration attacks, where people are trying to get through the open part of your application into the the data and where that's where that sensitive information is kept. Data protection. So use identity-based storage access controls. Don't just leave it kind of open to everyone. You've built in features for data encryption on Azure services. So if you create a storage account and you put data up there, encryption at rest is standard. But you also want to think about encryption for moving that data. When it moves between storage and a destination, making sure that anything over the network is encrypted. Make sure you classify all of your stored data. We spoke about that a little bit earlier. And access to these data stores, whether it's blob or something else. Using things like SAS tokens, keys and access. Make sure you're storing those in a managed key vault service, rather than kind of within any part of the application or anywhere it could potentially be consumed or read. And if you are using that managed key vault service, make sure you're rotating your keys and your other secrets frequently. So for applications and services that you are running, as we said, there's both legacy and modern applications, whether that's IaaS, running on virtual machines, or modern ones on platform as a service. We've already spoken about the shared responsibility model. Legacy applications, you've got responsibility for securing all the dependencies, including the OS, middleware, any other components. For PaaS services, you get rid of that OS, the underlying server OS you're not worrying about, but you're still responsible for the application's configuration, making sure that is secure. In terms of your application portfolio, organizations typically have quite a large number of applications that they look at, but not all have equal importance. Applications containing business critical data, regulated data, or with data with a high business value. If that data is highly visible or critical, you need to identify that and classify it. And that way, you can start to direct all of your sort of investment, whether that's your investment in money, your monitoring, your time and your resources appropriately to protecting what essentially are the most important parts of your application portfolio. Things that you should understand, from an application point of view. If it's a custom app that's built inside, application code. Beyond the code itself, security should be part of that design and implementation process. If you use third-party developers, assessing the supply chain, is a key element of security as well. If your application is running using Azure services, what underlying cloud services are being used by that application, what's the security for those cloud services. As we said, keep going back to it, shared responsibility model, understanding what is available and what you can kind of switch on to create a much more secure application you're deploying. Azure will always ensure the security of those underlying PaaS services, but you as application owner are responsible for the security implications of the configuration and operation of that service, as well as the configuration and operation of your application. Things to think about there is any data that's stored or processed by either the service or the application itself. And then the last thing to consider on apps and services, where are you hosting it? Is it on-prem? Is it infrastructure as a service, PaaS, containers? All of these have a different impact on the security of the application. So this is the last one on kind of the security pillar, and really this is focusing on creating new cloud native applications from scratch and what are the principles to adopt. So whether you got on the last thing, we were looking at designing applications, you might be limited by what you're deploying because of the software that you're using. This is building from scratch cloud native applications. What are the principles you should be adopting? So first one, plan resources and how to harden them. Always consider security when you're planning those resources. Understand how those individual cloud services for your application will be used, and then how you can protect them. Automate and use least privilege. We've spoken about least privilege a lot. Automation, look to drive automation through secure DevOps to minimize the need for human interaction. Classify and encrypt data. We've gone on about this a bit, so you should be aware of what we're looking to do there. And then monitoring system security and planning incident response. So we spoke about earlier, what does a healthy functioning version of my application look like? Understanding that, and then being able to correlate based on those events. Perhaps when an active threat is happening. Establish ideally automated, but also manual procedures to respond to those incidents when they come up, and use a SIEM for tooling for tracking. Microsoft Sentinel is the kind of obviously the Azure Microsoft SIEM, but obviously there are other ones out there. Identify and protect endpoints. So again, kind of if you've got something sitting out, an endpoint sitting out on the internet, using things like firewalls or web application firewalls, and we've spoken about things like DDoS. The stuff you get protected automatically with Azure, but obviously you have to upgrade that as well. Protect against code level vulnerabilities. So this really is about identifying and then mitigating code level vulnerabilities such as cross-site scripting and SQL injection. So looking at things like OWASP, there's a top 10 there, making sure that you're adapting to those and you're kind of scanning for those. In the operational life cycle where you've got your application, the release one's up and everyone's using it, start to incorporate regular security fixes and then code base and dependency patching. And then the last one there, model and test against potential threats. So, establishing procedures to identify and mitigate known threats. What are my known knowns? What do I need to protect against? Use pen testing, to verify threat mitigation. How well have I mitigated against those known knowns that people can test against? And then use code scanning to detect and prevent, future vulnerabilities and make it part of that DevSecOps cycle.